Hello, welcome to APES. We're going to go over some stuff for day one. Let's get started. My name is Mr. Justice. You can contact me at the email address on the screen or through the Canvas inbox. You can also set up or schedule an appointment for a live Google Meet during one of my office hours, 7:40 to 8, 9:40 to 10, or 12:10 to 12:30. So what is APES? APES is Advanced Placement Environmental Science, and it's a highly accessible course. Students love it because it oftentimes pulls from a lot of information that they are able to gather from previous science classes and even other classes like your history classes and English. So we deal with concepts that you might find in a biology class and a chemistry class or an earth sciences class. But we also have about 10 laws, acts, treaties that we need to know to be successful on the AP Environmental Science exam. More on that in the coming days, by the way. But yeah, we'll talk about ethics as it relates to the use of non-renewable or renewable resources, and politics, economics. So a lot of disciplines will inform our studies as we delve into this. This is what the curriculum looks like. We start off with kind of macrobiology, big picture biology with the living world. We'll get into ecosystems and ecology, right? Biogeochemical cycles, that's what these carbon, nitrogen, phosphorus cycles are. And then we'll deal with food webs, the transfer of energy, little photosynthesis to get in there to make it a full picture. Biodiversity in the second unit. We'll get into populations, human population concepts in addition to ecological concepts too. Unit 4 is all about earth science, weather phenomena, plate tectonics. Unit 5 is really fun to teach because we get into the impacts of agricultural practices, irrigation methods, integrated pest management. It's what I tell my students, it's one of the few classes in high school where you'll ever learn how to manage a piece of farmland and manage the pest problems that might exist there. So it's kind of interesting stuff all around, right? Very varied concepts and topics throughout, including there's the renewable and non-renewable energy kind of component of the class. Units 7 and 8 deal with pollution, air pollution, water, land pollution. If you've ever wondered where your waste goes after you flush the toilet, you will learn that in 8.11 of our curriculum. And then finally, the last piece of the puzzle here is our discussions and explorations into global climate change. Please make sure that you access the live session link for our live session classes through our Canvas class. And the reason why is because it helps out with tracking of attendance. If I didn't see you during the live session, or my extension that I'm using for attendance didn't work for whatever reason or didn't log you, then I will at least have a backup here, and I'll see that, well, you tried to get into the live session by logging in through Canvas. So that's pretty important right there, all right? Don't ever bookmark that link either, because we might change it throughout the different quarters or even weeks. The link doesn't matter, just the fact that the location of it is within our Canvas homepage, if that makes sense. But the specific link, location, yes, the link and what it says, no. All right, we're going to start with Unit 1 here. So this is the big picture here, right? I like to talk a little bit about systems, and you're looking at a system right here, right? Systems have inputs and outputs. There's different interrelated sets of parts. In the case of our Earth here, the parts are the biotic and abiotic factors that exist within it, the living and the non-living components of the system. In terms of energy, if we think of this system, this Earth, in terms of energy, it's going to be an open system in that, think about it, all of the energy that's available here on our Earth, the vast majority of it, right, is coming from the sun. Yeah, so it is, since there's an energy input coming from outside the system into the system, that it would be considered an open system. And the energy also, by the way, will dissipate back out through our atmosphere as it travels back into space. And so, right, it's leaving the system too. Now, in terms of this system, in terms of matter, it's going to be closed unless there's an asteroid that hits somewhere. There's no net increase or decrease of any of the matter on our world, right? All of the gold that exists on our Earth is either has been found or has yet to be found. Just like maybe the lithium that we might find in our batteries for our electronic components that we use. That's either been discovered or not discovered, right? So we kind of delve into those concepts throughout our class and those impacts that that phenomena have on other parts of the systems, Another example of a system here that got disrupted during the coronavirus pandemic has been the global food supply chain. I was just at Costco or Sam's Club the other day. I remember a couple months ago they had oranges from California, and I thought, oh gosh, okay, that sounds pretty good, right? I'm from California, Southern California, and I love a good Orange County orange. And so I go over to the Sam's Club area where the oranges are, and I'm looking for California orange, and I didn't see it. And just in really small text, it says the oranges that I had available to me in August are oranges from Chile. And then in finer print, it said packaged in New York. And then here they were being sold in Nevada. And so one of the reasons why there was a decrease in some of the food within our grocery stores at the very start of the pandemic was because of a disruption to that food supply chain system, right? You maybe no longer have a flight or a barge or some mode of transportation that can bring the oranges to the distribution center in New York. That's a disruption of it. And all of a sudden now you have all of these issues associated with that stoppage, right? So our systems here on this earth have existed in this fine-tuned balance for millennia. And one of the things that we explore in this class then is what happens when, what happens when one piece of that very fine-tuned components gets out of balance or removed or added to, in terms of like invasive species or an increase in pollutants in a waterway, whatever issue we're talking about. Anyway, it's kind of an interesting class, I think. I went to Yosemite over the summer, a little tent trailer camping, and right here you're looking at the half dome here in the very prominently in the center of this image. If you kind of look off to the right there, we've got some waterfalls, right? And you're looking here. And so in the live session, we talked a little bit about this system. This is an ecosystem, right? And just like a system is a set of interconnected parts that work together, an ecosystem is a set of interconnected parts working together too. Those interconnected parts are those biotic and abiotic factors. And during the live session, we talked about what some of those abiotic factors could be, and they could be the water itself because it's not living, right? The rock and the minerals in the rock. Think about it, the minerals in the rock can get even eroded away the more precipitation there is. There's another abiotic factor, right? The amount of precipitation in the area. So we might have an increase or a decrease of some of that erosion of the rock, and regardless of what happens, it starts to dissolve some of those minerals. It can get into waterways, so we can have an increase in salt water in an area or a decrease in it, depending on the amount of rain. So, or oxygen levels or carbon dioxide levels are available, or some of the ponds might have a certain pH that is really important for the plants and animals in the area to kind of maintain, right? So what happens if there's now an influx of additional chemicals into the area? What could happen to that fine-tuned balance? It'll get out of whack. Some of the biotic factors here in this area, the trees, the animals that aren't pictured here necessarily, right? But also the bacteria and the fungi and any of those decomposers that are really important in breaking apart that matter and freeing it up so that it can be used again. I like to say, like, we as humans are borrowing the carbon that we have that make up our body, right? We will return it someday. Hopefully a lot later than sooner. So here's another view of the Yosemite Valley. And one of the things I like to talk about here too is, or even here, one thing that none of my live sessions have talked about yet is the fact that humans are a part of this system too, right? There's a biotic human taking the picture on the other side of this camera. So what impact do the humans have on this? I'll tell you this, Yosemite Valley right here would not look like this if it weren't for human interaction, right? The river that runs through it nowadays stays pretty consistent in terms of its levels. But in the past, it might have had that seasonal flooding where a lot of those nutrients or sediments that have been dissolved by the rocks in the area, right? That it kind of rises up, the water rises up, and as it lowers down, it deposits that sediment and that very nutrient-rich components onto the soil, making the soil more nutrient-rich and more fertile to be able to plant and for plants to grow. And so if we dam up a river, that seasonal flooding no longer happens, right? Think about, it's called habitat fragmentation. There's two, you can't really see it here, but there's two roads that head up into this valley closer to this Half Dome area, these campgrounds. Think about cabins, people live there all the time, right? There's parking lots. So think about those human interactions right there. If you're a bear, you normally would have been able to move all about this ecosystem, but the moment there is a road that traverses your habitat, you no longer necessarily can move across that road without maybe being injured. During the summertime, I remember seeing just an article, a random article, talking about how there has been an increase in bear accidents in Yosemite Valley, specifically because of the increase in traffic through there. They've had to put up some signs to try to control it. But that's an impact of humans. Think about this, the more there is exhaust in this area, we're going to create more and more ozone available to us. The ozone in the stratosphere is really helpful in blocking out harmful UV light from the sun, but when it's down in the troposphere where we are, we breathe it in, it can impact our lungs, impact the lungs of other animals, but it also impacts the tissues of the giant sequoia trees that live and grow in this area. So we're decreasing the growth rate of these other species as a result, right? All of these actions have consequences. Sometimes they're unattended, sometimes they're out of whack or out of balance, but there's consequences once you move one of those cogs, one of those parts that make up this system. Another thing, you don't want to have, there's cabins, like I said, there's campgrounds and infrastructure back here, so you really don't want to have any more fires anymore. The problem with that is that the giant sequoia trees actually require fire in order to be able to reproduce and grow. Their seeds need to have fire-touched soil in order to be able to germinate and grow. So just the fire suppression aspect of it is a way that we're, decreasing biodiversity, right? One solution, that we always try to talk about solutions to a lot of these problems that we talk in environmental science, and one of them is to do a prescribed burn. And a prescribed burn will contain the fire. It's human caused, but it's on purpose, and it tries to contain the fire and make sure it doesn't spread, right? But it's important that that fire does touch that soil so that reproduction can occur. So we delve into, we talk about land management issues too in APES. It's an interesting class. So there's more to the story. I kind of ran out of time during the live session with everybody, and so I've got more slides that I'll tell you. But the assignment, there is an assignment, so you make sure that you get down to the Canvas class through ccsd.clever.com or ccsd.instructure.com. And then there's it's not called class instructions in Mono Lake, but it's close to it. Look for the article about, or assignment about Mono Lake. And I'll tell you more about Mono Lake during the next session that we talk. Let me show you how to do this though. So now I'm in my Canvas class. It's going to look a little different from yours because this is the teacher version, but take a look. This is where you found the video for this. It's not here yet because I'm making the video. There's your slide deck for today, and then right here, the 3-minute read. So you click on this. It shouldn't take you more than 3 minutes to read it, and a couple moments more to respond. Read the instructions up here, Got a nice little article, talks a little bit about food webs, which is what we have to do if you remember seeing that in the video earlier. So it's something we have to talk about, so let's talk about it now. Anyway, here are the questions. Go through, write a response. How do you do that? Take a look. You can't see any other posts yet if you're a student until you post first, and I've removed your ability to edit. So don't just like post anything hoping to fix it later. You got to make sure that you kind of take your time with it, right? So click in within that text field where it says post. Type out your response here. You can change the fonts, add subscripts or superscripts, whatever you want, tables, and then post reply. I'd like you to get in there and read a couple of your others and even reply to a couple of your other peers within the class, all right? If you have any questions, you can contact me through inbox on Canvas. Take a look, here it is right here on the browser version, or you can email me at justucr@nv.ccsd.net. See you next time.